So let's expand a little bit on what happened in that last example, right? So we were on an open interval, right? From 0 to infinity, right? Open interval, one with the parentheses. um, but even if it were a closed interval, or a half closed interval, like bracket 0 to infinity, we still have this kind of result here, right? So we only had one critical number. Okay. Since we only had one critical number, we can run the first derivative test on it. And, if the first derivative test comes back with it being a local maximum or a local minimum, then it in fact has to be absolute, right? So why does that have to be the case? Well, let's say here, right? So we have c is a critical number of this continuous function f, and it's defined on an interval, right? So there's no gaps in it anywhere. It's defined on a whole interval. Here in part A, if the derivative is positive for x less than c and negative for x greater than c, then c has to be where the maximum occurs, right? And that has to be the case because our function goes up all the way until x equals c. And then since the derivative becomes negative there, it has to go down. And it doesn't matter how far it goes down, but we know since it goes up all the way to c and down all the way after, we know two things. One, there can be no other critical numbers because this doesn't allow any possibilities for f prime equals 0 again, or undefined. But also, we know it has to be the absolute max. Right? And likewise, the same reasoning gets us to if the derivative is negative before c and positive after c, it forces us to say, oh, derivative's negative, we're going down, and then here's x equals c. And then, oh, derivative's positive, all right, well, it has to start going up again. Right? And again, you could get weirder shapes like this maybe. Here is x equals c. It doesn't have to be a parabola every time. But it always, is sort of forced to be an absolute max or min here because there's no place for the function to turn around, right? Both of these situations allow for exactly one turnaround point for the function, and it's at this one critical number, right? And since it can only turn around once, in part A here, we might not have an absolute minimum, and in part B here, we might not have an absolute maximum, but we're not interested in that case, right? Or we're not necessarily interested, but we can't say anything. But usually if we're using this theorem, we're trying to get, exactly one of these two results to happen.